The last question in the 6.2 alternative examples has to do with speed daters. And ultimately, after you read this question, it's going to be what is the probability that a male speed dater is taller than a randomly selected female speed dater? Why don't you press pause on the video, read this for a second, and then come back. Okay, so for this problem, it looks like the males are typically taller than the females. The males are 70, the females are 65. Males are about 5 inches taller. The males are varying a little bit more, have more variation than the females, but it's possible that a randomly selected guy is shorter than the randomly selected girl, or vice versa. And so if you look back at those notes that I was referencing in 6.2 in the other video, here's the situation if I could do it in a picture here. We have the males that are a little bit taller, their average height, mu of a male is 70 inches, and the sigma for the males is 3.5. So typically they're about 70 inches, give or take about 3.5 inches, whereas the females are 65 inches, give or take 3 inches. It says that the distributions are normally distributed, which means if you looked at like the 500 male daters in this room, the average is 70 inches, but there's some that are 71, 72, 73, there's some that are 69, 68, but the distribution of males in the room is normally distributed, and the distribution of females is normally distributed. And we're trying to figure out what's the probability that the male will be taller than the female. And so what I'm going to say here is I'm going to say this. If we subtracted the male height minus the female height, so like the typical male is 70 inches, the female is 65. If we subtracted 70 minus 65, we would get a difference of 5. And that positive difference of 5, any positive difference would mean that the male is taller. A negative difference would mean that the female is taller. So I'm going to let D be the event that the difference of a male minus female that's going to be what my letter D is, my random variable D. Okay, so what is going to be the center of our distribution D? So what we have is I'm going to make a curve that puts these two curves together, a difference curve. So if I say that my difference is male minus female, and I do 70 inches minus 65 inches, the typical difference here in the males versus the females is about a 5-inch difference. So that's the average, the center, is 5 inches. And that's just 70 minus 65 is that. Now, the harder part always comes down with the standard deviation. Last time I told you that the standard deviation has to work, you have to work with variances. You have to work with the square of standard deviations, much like you do with the Pythagorean theorem. But there's one also added twist here. Because sometimes students see the subtraction in this problem and they think, I'll just subtract the male standard deviation minus the female standard deviation. Or they'll subtract the male variance minus the female variance. Either way, you don't want to do that. You see, these males can vary up and down. The females can vary up and down. When you have variation happening in the male and variation happening in the female, that means the variation is happening in two different parts of our system. And whenever one thing is changing and then the other thing is changing, then together there is a lot of change that's happening here. There's a lot of differences that could exist. And because of that, there is this final rule in 6.2 that variances always add, even if the problem is a subtraction problem. And the reason is because the male height is varying, the female height's varying, and so if we look at them together, there could be a ton of varying that's happening. So in this case, to find out the standard deviation of the difference, the male minus female difference, we do the variance of the difference is the variance of the males plus the variance of the females. That's 3.5 squared plus 3 squared. And if you put that together, you get 21.25 inches squared. And then if we square root both sides, we find out that the standard deviation of the difference is the square root of 21.25 inches. So I'll put that right here in my curve. Now, a reminder, we're trying to figure out what is the likelihood of the males being taller than the females? So we're actually looking, I'm sorry that I shaded this in my notes here, but we're actually looking for this really big percentage. It's way more than 50%. And so how do we do that? Well, we're going to do the probability of the difference being greater than 0, right? Because typically the males are 5 inches taller. That's a positive difference. So any positive difference means the males are taller. So we're going to do the Probability of the difference being greater than or equal to 0 is normal CDF of low at 0, high at a billion or a million, average is 5, standard deviation is 21.25, and we find out that the probability of this happening is 86.096% of the time.